All right, guys, we are going to cover the second section of Chapter 9, which is solving quadratic equations by graphing. And since we're graphing, you're going to need some graph paper for this lesson. Okay, we've got a couple of key concepts to go over, so please copy this down, and we'll go over it when you're finished. All right, the first one is quadratic equation, and this is an equation written in the form y equals ax squared plus bx plus c, where a cannot be 0. And then we've also got roots, which is the solution of a quadratic equation is known as a root. And we can find our roots by finding the x-intercept or zeros of the related quadratic function. Okay, well, we're going to be really looking at the x-intercepts because we're graphing today. And remember, we talked about x-intercepts when we talked about linear equations, as the x-intercept is where it crosses the x-axis. Okay, now these are a couple important points. We've got quadratic equations always have 2 roots because it's to the second power. We've got 2 roots. But sometimes we have roots that are the same number. And this means that it's a double root. And sometimes we can also have the roots being not real numbers. Okay. Here's our first example. We've got solving the equation by graphing. X squared minus 2x minus 3 equals 0. Just a quick little note. As you can see in my y, where my y usually is, I have an f of x, and that's just the symbol for function. So function f of x is the same thing as saying y is the same thing as saying equal to 0. So of course you always want your equation equal to 0. And if it's equal to 0, you can replace it with f of x. So that's what I'm going to do here. Replace it. Basically, it's called a related function. F of x equals x squared minus 2x minus 3. Okay, and then the last lesson we learned how to graph this, and we find our axis of symmetry. And we plug in negative b over 2a, and we plug in here, we get x equals 2 over 2 times 1, and x is 2 over 2, which is 1. And we find our vertex by plugging in our axis of symmetry into our equation here. And we say 1 squared minus 2 times 1 minus 3, which is 1 minus 2 minus 3 minus 1 minus 3, and we get minus 4. So our point here is 1, negative 4. Okay, so we come here, we plug in 1 and negative 4 into our graph, and we want to choose numbers above and below our 1 so we get a good graph. So we're going to choose 0, negative 1, negative 2, and 2, 3, 4 here. Now we learned how to graph this before, so I don't want to go through it again, but basically what you do is you just plug in your x values into your equation here. So I'll do 1 just for the sake of it, and we'll do 0 here. 0 squared minus 2 times 0 minus 3, 0 minus 3, and that's negative 3. So you'll do that for each one of these values. But for time's sake, I'll just fill them in for you. This one's 0, this one will be 5, this one will be negative 3, this one will be 0, and this one will be 5. So we come over to this graph over here, and we're going to plot these points. We've got negative 2, 5, negative 1, 0, 0, negative 3, 1, negative 4, 2, negative 3, 3, 0, and 4, 5. Okay, make a nice smooth parabola here. Okay, now remember our solution is where it crosses the x-axis. Well, here is where it crosses, and this is our other cross. So we have our roots, our solutions being negative 1 and positive 3. Okay, so we come over here, and I want to show you a little trick. Remember when we talked about how when we have y equals 0, that's our x-intercept. When y equals 0, we'll look here, we've got y equals 0 here, y equals 0 here, and look at our x values, and look at our roots. Do you see that they're the same? So you can always kind of reference your chart to make sure you're doing this right. Okay, now I want you to try this example, and when you're ready for the answer, replay me. Okay, so we get f of x equals negative c squared plus 5c minus 4. Your axis of symmetry is x equals positive 5 halves. And you plug in for your vertex, and we get our vertex to be 9/4 or 2 1/4. Okay, so our point is 5 halves, 9/4, or that's the same thing as saying 2 1/2 and 2 1/2 and 2.25. So we're going to come here to our middle, and we got 2.5 and 2.25. So we want numbers above and below. And then we get 2, 1, 0, 3, 4, 5. We plug in, we get negative 4, 0, 2, 2 1/4, 2, 0, negative 4. Okay, so you should plug those values in yourself and be able to get those. All right, and then we go from 0, negative 4, 1, 0, 2, 2, 2 1/2, 2 1/4, 3, 2, 4, 0, and 5, negative 4. And here we get our smooth little parabola here. Okay, and then where it crosses the x-axis is where our roots are. So we've got our roots being positive 1 and 4. All right. So here's our next example of being 0 equals x squared plus 6x plus 9. So we're going to change this to f of x, our related function, x squared plus 6x plus 9. We get our axis of symmetry, figure out negative b over 2a, and we get that to be x equals negative 3. And we plug that in to get our vertex, and our vertex becomes 0. So our point here is negative 3, 0. So we come over to our chart, we plug in the middle negative 3, and our vertex point is 0. We want values above and below negative 3, so we choose negative 4, negative 5, negative 6, negative 2, negative 1, 0. And this becomes 9, 4, 1, 0, 4. Oops, did I mess up? 1, 4, 9. Excuse me. Okay, so then we want to come over to our point here in our graph. We graph negative 6, 1, 2, 3, 4, 5, 6, 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. Up here, negative 5, 4, 2, 3, 4, negative 4, 1, negative 3, 0, negative 2, 1, negative 1, 4, and 0, 9. Okay, now this one is a little different than the last one in the sense that we are only crossing the x-axis one time. Okay, does everybody see how this one is different than the previous one where we have a different color? 2 places where it crosses the x-axis? Well, in this case, we only have 1. So we have a double root. And this number is going to be repeated twice because I need 2 solutions, and this is negative 3, a double root at negative 3. Okay, I would like you to try this one. Make sure before you start this one that you have your equation equal to 0. Now pause me and replay me when you're ready for the answer. All right, so we have f of x equals b squared plus 4b plus 4. And we have our axis of symmetry being x equals negative 2. And we plug that in for our vertex, and we get 0 when we plug in. And so our point is at negative 2, 0. So we come over to our chart here. We plug in negative 2 and 0. And we want numbers above and below, so we get negative 3, negative 4, negative 1, 0. When we plug in here, we get 4, 1, 0, 1, 4. Okay, so then we come over here and we plot our points. 4, 1, 2, 3, 4, 3, 1, negative 2, 0, negative 1, 1, and 0, 4. Okay, again, you can see that these are only, this graph is only crossing the x-axis one time. So this has a double root at x equals negative 2. Okay, so our solution, or our root, is at negative 2. Again, we can see over here by our chart, whenever y equals 0, your x-intercept is negative 2. Okay. All right, so this next example, I want to show you an example of when it is not a real number solution. Okay, and that means that we've got to make this, first of all, into f of x. Okay, and then from here we got to get our axis of symmetry again. Our axis of symmetry here is x equals 1/2. And we plug in for our vertex. And we go all the way down. We have 3.75 or 15/4. And so our point is at 0.5, 3.75. So we come here to our middle. We get 0.5. 3.75, and we want numbers above and below 1/2. We have 0, negative 1, 1, and 2. We plug in, we get 6, 4, 3 3/4, 4, and 6. So we come over here and we plot negative 1, 6, 1, 2, 3, 4, 5, 6, 0, 4, 1/2, 3.75, 1, 4, and 2, 6. Okay, now notice your difference between this one and the last one, where we had one vertex, or the one a couple ones before where we had 2 crossing the x-axis. And now this one, it never crosses the x-axis. Okay, this graph, because it goes on and on and on and on and on in the positive direction, I will never ever cross this x-axis. Okay, so this one has no solution, or null. You want to write the empty set. This is the symbol for an empty set. No solution. Okay, and then finally, we also touched on this in Chapter 8 with factoring. And we can factor a quadratic equation by, or we can solve a quadratic equation by factoring. And we do that, remember, we find the factors of negative 12, which we get to be negative 3 and positive 4, because remember, we want to add up to being a positive 1. So we rewrite this as x squared minus 3x plus 4x minus 12, group these together, and we factor out an x, x minus 3, factor out a 4, x minus 3. We can rewrite this as x minus 3, x plus 4. And this is just because I have f of x here. Remember before I said f of x equals y equals 0. Those are all interchangeable. So when it says f of x, I can replace that with a 0 here. So this is just like before we saw in Chapter 8, x minus 3 equals 0, x plus 4 equals 0. And we add 3 to both sides, we get x equals 3. We subtract 4 from both sides, and we get x equals negative 4. So my solutions here, we've got 2. It says use factoring to determine how many times the graph of each function intersects the x-axis. Since I get 2 solutions, it intersects it at twice. And those solutions are 3 and negative 4. Okay? So now here's your practice problems. I'd like you to try these first 3 by using graphing. And I want you to solve these 2 by factoring. Okay, first of all, determine how many times the graph of each function will intersect the x-axis, and then identify your roots. So just like we did here, it's twice with 2 roots, 3 and -4. Okay. Please remember to add in your questions at the end of or in the margin of your paper. And happy practicing. I'll see you tomorrow.